Hello students, good day to all. Myself Yusuf sir. So today we are going to learn about geometry. In that geometry part, first lesson it is lines and angles. So before going to lines and angles, I'd like to tell you the definition of geometry. So geometry, it is a branch of mathematics which deals with the study of shapes, size, relative positions and figures and the properties of the spaces. So that means here in this whole chapter you are going to study about these things only: shapes, size, positions, figures, properties of the space. Everything you are going to study in this chapter. So now let's go for the lines and angles. What are the things you are going to study about the lines and angles? See, lines and angles, name itself suggests everything geometry starts with lines and angles only. So this is the most important lesson or a chapter as per geometry point of view. This lesson, if you are able to understand this chapter, that means you are going to fix your basic things of which is related to the geometry. Okay, so in this chapter we are going to study about the points, basic terms and definitions, intersecting lines, non-intersecting lines, angles and its types, axioms and theorems, perpendicular lines, parallel lines and transversal lines. See, these things you are going to study in this chapter. So these are the most important things. Along with these things we are going to solve the exercise problems. Okay, so let's go for the first thing, that is points. So geometry starts with a basic unit, that is point. That is, what is point now? It is an exact location of anything, or you can say it is a small dot on a plane surface. If you just see a point, it is a dot. It is a dot on the what? It is a dot on a plane surface. Okay, next it is collinear points. So if it is single point, it is called as single point. If one or more point arises, then it is called as points. Now when do you call them as collinear points and when do you call them as non-collinear points? If three or more points lie on the same line, they are called as a collinear points, or else they will be called as a non-collinear points. Now if you just see, all the 3 points are in a single direction, therefore they are called as a collinear points. Here you can see that they are all in a different lines, therefore they are not in a single line, therefore they are called as a non-collinear points. Next are basic terms and definitions. Now what are these basic terms? So let us start with the line. So a line, it is a straight path extended in both the directions with no end points. If you see that figure, there is no end point there. As you can see in the second figure, AB, there are end points. In the first figure, there are no end points, means it can be extended in both the directions, such it is called as a line. Now second is line segment. It is a part of a line with 2 end points. See the diagram there. There are 2 end points for that line, that is A and B. A and B are the 2 end points over there. So it is called as a line segment. Means line segment, it is a part of a line with the 2 end points. Then only you call it as a line segment. Now third concept, it is ray. What is a ray? A part of a line with one end point that continues without end in another direction, in one direction. Just see the figure. In the figure you can see that there is one end point. In other side there is an arrow mark, which means it is extended in other direction. Okay, so next is intersecting lines and non-intersecting lines. What are these intersecting lines? Intersecting lines, that the lines which cross over each other. If you see the diagram, they are crossovering with each other. Just see the diagram there. One line, it is intersecting with the other line, then they are called as a intersecting lines. Non-intersecting lines, these are the lines which do not intersect with each other. Just see the figure. PQ, there is a line, and RS is also a line. They are not intersecting at any point. Okay, now let's go for the next bit, that is types of angles. So it is formed when 2 rays originate from a same end point. Then the ray which forms an angle is called its arm, and the end point is called as a vertex of that angle. If you just see the figure, there A is a vertex, means from the point A two rays are arising. If two rays they are meeting at one point, then there is an angle formed. Or if two rays which are arising from one point, means originating from one point, then their angle is formed. And angle always have one at vertex, okay, two arms it will be having, okay. So the vertex A, it is having two arms, that is two rays. That two rays are called as arms. Now when there is an angle, there are types of angles. Which are those angles? Let us discuss one by one. So first we are having acute, then comes right angles, obtuse angles, straight angles, reflex angle, complementary angles, supplementary angles, adjacent angles, linear pair of angles, and vertically opposite angles. These are the types of angles. So one by one we are going to study about these angles. What are the properties of these angles? Okay, first comes is acute angle. Now what is this acute angle? It is an angle whose measure is between 0 degree and 90 degree. Means if that angle's measure, it is this angle, if it is measuring between 0 and 90 degree, then it is called as a acute angle. So whenever this angle it is less than. So which are the examples? If you just see the diagrams over there, there is a pie of cake, it is there is a pie of pizza, it is there, and the laptop's angle it is making, that is less than 90 degree. If you see the road, there is a road angle between the two roads, that is also less than 90 degrees. And if you see the watch, the timing they are showing from 12 to 2, it is also less than 90 degree, that is also acute angle. And see the scissors, the ends of the scissors, they are also bent to each other in which in between those what you call arms of that scissor, there is angle which is less than 90 degree. So it is called as a acute angle. Okay, so next is obtuse angle. Okay, next is acute right angle. So when do you call it angle? It is right angle. So it is an angle whose measure is equal to 90 degree. We have studied that if the angle was less than 90 degree, it was acute angle. Now if the angle is exactly equal to 90 degrees, then it is called as a right angle. If you just see the diagram, this angle it is equal to 90 degrees, so it is called as a right angle. Okay, so if you see all the examples over here, they are all the angles are, if you see the edge of the door, you can see the wherever the red mark, it shows the angle there. So all the red mark what is showing, it is as a right angles. So if you take the chair also, if you take the frame also, if you take the house also, you can see that there is a there in the watch also you are going to see that 90 degrees it is there. So these are the examples of the right angles. Okay, so next is obtuse angle. So what do you call, when do you call the angle as obtuse angle? So it is an angle whose measure is 90 degrees but less than 180 degree. So if this angle is greater than 90 degree and less than 180 degree, then you call it as a obtuse angle. So here they are given that if the angle is greater than 90 but less than 180 degree, then this angle you call it as a obtuse angle. So what are the examples? If you just see that a rhombus angle, the angle between the two sides of a rhombus, it is greater than 90 degree, therefore it is a obtuse angle. If you see the angle between the head and wings of the plane, it is also greater than 90 degree, so there also you are going to say that it is a obtuse angle. So next there if you see the piano, if it's the angle between there also you are going to see that the angle is more than 90 degree and less than 180 degree, therefore it is a obtuse angle. And see this figure also, the stand, there also the angle is more than 90 degree, less than 180 degree, therefore it is a obtuse angle. If you see that screen of the computer here, that is also greater than 90 degree but less than 180 degree, therefore it is also obtuse angle. This is all about the obtuse angle. Next comes is straight angle. What is straight angle? It is the angle whose measure is equal to 180 degrees, then you call it as a straight angle. So if you this angle, if you just see this angle, it is equal to 180 degree, therefore it is called as a straight angle. So always a straight line has 180 degrees itself. Okay, so if you just see the steps in the bottom of the steps, they have showed it in the purple color, that is straight angle. And if you see the timing watch also, the angle between 12 and 6, it is 180 degrees only, straight, and therefore it is called as a straight angle. Okay, next comes is reflex angle. So it is angle whose measure is greater than 180 but less than 360 degree. So that kind of angle we call it as a reflex angle. If the angle is equal to 360, it is called as complete angle. Now here in this reflex angle, it is less than complete angle, greater than straight angle. Means here you are going to see that this angle you are going to say it is a reflex angle. Therefore the angle which is measures whose measures is greater than 180 degree but less than 360 degree, you call it as a reflex angle. Next comes is complementary angles. What kind of angles you call it as a complementary angles? Okay, the two angles whose sum is 90 degree are known as complementary angles. If you just see the diagram there, you can see that angle A and angle B, if you add them both, you are going to get 90 degrees there. Such angles you call it as a complementary angles. Okay, the two angles whose sum is 90 degree are known as complementary angles. And for the figure shown above, the sum of angles A and B is 90 degree, hence these two angles are complementary. So if you add A plus B, that should be equal to 90 degrees. Such angles you call it as a complementary angle. Next is supplementary angle. We have studied complementary angle, the sum is 90 degree, then it is called as complementary. But now supplementary, if two angles whose sum is 180 degree are known as supplementary angles. See the diagram there, 45 degree and 135 degree. If you add them both, you are going to get 180 degrees. For such figures, you are going to tell that for such angles you can say that they are supplementary angles. Remember this, complementary and supplementary. If the sum is 90, it is complementary, and if the sum is 180 degree, it is supplementary angle. So next is adjacent angles. What are these adjacent angles? Two angles are said to be adjacent if they have a common vertex, a common arm, and their non-common common arms are on the different side of the common arm. Just see the figure. Just see the figure. Now there is one common arm here. They are having a common vertex B here. Okay, so they are having one common vertex and one common arm, and non-common arms are these and this are on the either side, opposite side of the common arm. Such angles you call it as a adjacent angles. Okay, now it is a common arm, and this is a common vertex. These are non-common arms. They are on the opposite side. One is here and other is here. They are on the opposite side of the common arm. If such condition arises, the angle formed are adjacent angles. So these angles will be called as the adjacent angles. Okay, now this is what the angles are there. When two angles are adjacent, their sum is always equal to the angle formed by two non-common arms. See, whatever, when there are adjacent angles are there, if you add them both, you are going to get a complete angle. Okay. Okay, so ABD and DBC are adjacent angles. If you add them both, you are going to get a ABC angle. Okay, now let's go for the next part, that is a linear pair of angles. What are these linear pair of angles are? So two angles are said to be linear pair if their adjacent angles formed by the two intersecting lines. The linear pair of angles must add up to 180 degree. Just now we have studied about complementary angles, supplementary angles. Now same here, if you just see, the linear pair of the angles must add up to 180 degree. Means these two angles which are on the line, they must add up to 180 degree. Such angles we call it as a linear pair. Means if the angles, two angles sum, or more than two angles are there, if their sum is equal to 180 degree, then all those angles are called as a linear pair of angles. For example, if you just see the figure, what a ray BD is standing on the line AC. Okay, this ray, it is BD, it is standing on a line AC. Okay, now if it is standing over there, this angle plus this angle, if you add it, it should be equal to 180 degree. Such angles you call it as a linear pair of angles. Okay, ABD and DBC are linear pair here, because if they add them, you are going to get a 180 degrees. Okay, next is vertically opposite angles. Now what are these vertically opposite angles? The name itself says they are vertically opposite. Means these are the angles opposite to each other when two lines crosses. If you just see the figure there, two lines are crossing. Okay, when two lines are crossing, now this angle is opposite to this, vertically opposite, and this angle, it is vertically opposite to this. So vertically opposite angles here are, angle AOC is opposite to angle BOD, that is vertically opposite. These two angles are vertically opposite angles. Similarly, these two angles are vertically opposite to each other. Okay, now next is such angles you call it as a vertically opposite angles. So next is pair of angles. Now see, for pair of angles there are two axioms here. These two axioms you are going to use while proving your solutions or proving your theorem. So these two axioms are most important. Just understand it. If you have understood what are the complementary angles, supplementary angles, linear pair angles, these axioms are nothing. Okay, axiom 1 says, if a ray stands on a line, then the sum of two adjacent angles so formed is 180 degree. So if a ray, see, suppose if a ray is standing on a line, a ray here, if you see both the diagrams over there, RS is standing on PQ, and in second diagram BD is standing on AB. See, RS, it is standing on PQ, and BD, it is standing on BC. Now if there is a condition, if a ray is standing on a line, then sum of two adjacent angles. So what are the adjacent angles here? Angle RSP and RSQ. These two angles are adjacent to here. So this plus this should give you 180 degree. Similarly, this plus this should give you 180 degree. This is what axiom 1 says. If a ray is standing on a line, then sum of two adjacent angles so formed is 180 degree. This is what axiom 1 says. So okay, next is axiom 2. Okay, wait. Axiom 2. What does that axiom 2 says? If the sum of two adjacent angles is 180 degree. Now we have studied that if a ray is standing on a line, then sum of two adjacent angles is 180 degree. Now you reverse of this. If the sum of two adjacent angles is 180 degree. Now if two adjacent angles are there, if you add them both, if it is equal to 180 degree, then the non-common arms of the angles form. Now non-common angles will be these two, PS and SQ, AB and BD. These are non-common arms. The non-common arms of the angles will form a line. They will be a line. Then PQ and AC will be a line. This is what axiom 2 says. If the sum of two adjacent angles is 180 degree, then the non-common arms of the angles are they will form a line. See, now this plus this, if it is equal to 180 degree, then this will be a line. Okay, now let's go for the theorem 6.1. Now what does this theorem 6.1 say? Now let us find out first what is the statement of this theorem. Statement says, if two lines intersect each other, then the vertically opposite angles are equal. So if you just see here, AB and CD, they are intersecting. Now they are intersecting at point O. So we have to prove that vertically opposite angles, this angle it is equal to this angle, means AOC it is equal to BOD, as well as we have to show that, or we have to show at least one. If you show, it is okay. If you want to show both, you can show both. Okay, now AOD it is also equal to COV here. Okay, now if you just see AOD it is equal to BOD, or you can show this AOD it is equal to COB. Either you show AOC equal to BOD, or you show AOD it is equal to COB. Both are same. Okay, next, first whenever you are going to prove the theorem, first you need to write what are the first statement, then what are the given things, what are the things you are going to prove, then we are going to prove it. Okay, first we are going to write what are the given things. We are assuming that AB and CD are two intersecting lines which are intersecting at the point O. So remember students, so whenever in geometry you have to be so attentive that everything it is related to the diagram. So every step you are going to compare it with the diagram itself. So your concentration should be on the diagram. Okay, so first we are assuming that AB and CD be the intersecting lines at point O. Now if you just see, AB line is there and CD line it is there, they are intersecting at the point O. Now this is we know. Okay, so what are the things we are going to prove? We are going to prove that, just a second, we are going to prove that angle AOC it is equal to angle BOD, or angle AOD it is equal to angle BOC. Remember this one, that only we are going to write it now. We are going to write as what is the things we are going to prove. We are going to prove that vertically opposite angles AOC it is equal to BOD and angle AOD it is equal to BOC. Now to prove that one, now we are going to write the proof. Now what are the things we are going to write in the proof part? So in the proof part we are going to observe the diagram. So most importantly, remember this one, that whenever you are solving or proving anything in the geometry, you are going to relate it with the diagram. Without a diagram, if you are writing anything, that carries 0 marks. Remember this one. With the base of diagram only, everything you are going to prove it. Okay, now just see the diagram. Now ray AO it is standing on CD line, it is a CD is a line and AO is standing on the CD. Okay, when we have by axiom 1 what linear pair of angles it should be equal to 180 degree. So by axiom we say that axiom 1, when a ray stands on a line, then the adjacent angle sum it is equal to 180 degrees. So we are going to write ray AO stands in the proof part. In the figure, ray AO stands on the line CD. Now when it is standing on the line CD, then their linear pair angle sum it should be equal to 180 degree. Therefore we are going to write angle AOC. Now this angle plus this angle it should be equal to 180 degree. We are writing it as, therefore angle AOC plus AOD it is equal to 180 degrees. So this is what, why we are writing linear pair of angles. So their sum it is equal to 180 degree because it is standing on a line. Now similarly, what you are going to write? Similarly, ray OD. Now this ray, if you just observe, this ray it is standing on the line AB. So what we are going to write? Similarly, that ray OD it is standing on line AB. So we have written it as, similarly ray OD stands on the line AB. It is, if it is standing, then the linear pair should be equal to 180 degree. So we are going to write, and therefore angle AOD plus angle BOD it is equal to 180 degree. See this angle as well as this angle, AOD plus BOD it is equal to 180 degree because it is standing on a line, means it is a straight angle. Straight angle it is equal to 180 degree. So we are writing it as AOD plus BOD it is equal to 180 degrees. So we have written the reason again, linear pair. Now we have got two equations. First equation it is AOC plus AOD it is equal to 180 degree. So this is what it is. And second equation it is this, AOD plus BOD it is equal to 180 degree. If you look at both the equations, they are equal to 180 degree. Means equating. They are, both the equations are equal to 180 degree. That means we are going to equate both the equations now. Why? Because both are equal to 180 degree. So equating equation 1 and equation 2. What happens when you equate both the equations? Now this part, left hand side, that is AOC, angle AOC plus angle AOD, it should be equal to angle AOD plus angle BOD. So this is what we are going to write it now. What? Angle AOC plus angle AOD, it is equal to angle AOD plus BOD. We have written it. Now if you just see that equation, what is happening there? Now just see, AOD is present on both the sides. What happens if I take one AOD to this side? What happens? Now when you take that one AOD to this side, this will become negative. That means one AOD minus other AOD, that will be equal to 0, means AOD minus AOD, it is 0. Therefore that AOD get cancels. So what is left? Only left thing is AOC equal to BOD. That is what we wanted to prove. If you just see the what to prove, this is what AOC, it is equal to BOD. We have proved it. Now we have proved that AOC, it is equal to BOD. Same criteria, it can be used to prove that AOD, it is equal to BOD. That is left to you. That you have to prove it. That is the homework for you people. What you have to prove? AOD, it is equal to POC. To prove that one, what you have to take? I'll just give a clue for you people. What is that clue? So you have to take that ray BO is standing on CD, and one more you are going to take it as ray OC is standing on AB. Ray OC is standing on AB. You have to take this one and solve the theorem. This completes your theorem 6.1. So in the next class we are going to discuss about the exercise questions. We are going to solve the exercise questions. We are going to solve, and using these concepts only, these basic concepts only, we are going to solve the problems over there. So get perfect in this part. We'll solve in the next video we are going to solve the exercise questions. Okay, thank you.